Problem 14. Assuming ideal flow in a horizontal plane, calculate the magnitude and direction of the resultant force on the stationary blade, knowing that the velocity of the jet is 15.25 meters per second and that the diameter of the jet is 150 mm. Note that the jet is divided by the splitter so that one-third of the water is diverted toward A. So this is the given figure. Let's solve for the total Q first. So Q is pi times radius 0.075 square times velocity 15.75, 0.2783 cubic meter per second. So that Q upper or QB is Q upper times density is 2/3 of 0.2783 times 1000, 185.5 kilogram per second. So remember the formula for Fx and Fy is Q rho quantity for Fx V1x minus V2x, and for Fy Q rho quantity V1y minus V2y. So therefore Q of the lower times density or the mass flow rate for the lower portion is one-third of Q 0.2783 times 1000, so 92.77 kilogram per second. So let's divide the portion into two parts. Let's compute for Fx upper and Fy upper, and Fx lower and Fy lower. So Fx upper is 185.5, velocity V1x is 15.25, then minus V2x 15.25 because the flow is ideal. So 15.25 cosine of 60, that's the x component of velocity at point 2, which is here. So therefore Fx upper is 1440 newtons, and that's rightward. Fx lower or Fy upper, Fx lower first, 92.77 times 15.25 minus, since the x component of velocity is going to the left, so it is negative 15.25 cosine of 60 degrees. So this is also 60 degrees here. So Fx lower is 2122 newtons. Therefore, the resultant horizontal force is the sum of these two, which is rightward as shown in the figure. So Rx is 1414 plus 2122, 3536 newtons rightward. Then Fy upper, 185.5 quantity V1y is 0 minus V2y going up, so 15.25 sine of 60. So it is negative 2450 newtons, Fy upper. Then Fy lower is 92.77 times V1y 0 minus, because V1 lower is going down, it is negative 15.25 sine of 60, the vertical component. So it is positive. So it is 1225 newtons. Therefore, Ry is 1225 upward minus 2450. So Ry is negative 1225 newtons. So the resultant Ry component is going down as shown in the figure. Therefore, the resultant force on the stationary plate, resultant force due to the water impinging on this stationary splitter, is down to the right, and with a magnitude of square root of 3536 square plus 1225 square. So it is 3742 newtons. Down to the right with an angle with the horizontal theta x 19.11 degrees, where 19.11 is arctan of 1225 over 3536. Our tangent theta x is y component over x component. So theta x is 19.11. So that's the angle that the resultant force makes with the horizontal. So that's it for this problem.